Week 1's finished. Let us now proceed to week 2 of quarter 1, wherein we have to determine arithmetic means and the nth term of an arithmetic sequence. Needless to say, but I'll say it anyway, we are going to be introduced to our first type of sequence called an arithmetic sequence. Let us now define what an arithmetic sequence is. So an arithmetic sequence is a sequence where every term after the first is obtained by adding a constant called common difference. This common difference is also a new term to us, so let us define what a common difference is. So a common difference is a constant derived by subtracting any two consecutive terms. So we have our sequence here 3, 7, 11, 15, 19. Let us identify first if this sequence is arithmetic. How do we find out if this sequence is arithmetic? So we should identify if terms are obtained by adding. And what do we add? A constant called common difference. So we have here 3, 7, 11, 15, and 19. So if we take one term, let's say for instance, I take 7, and I subtract 3 from 7, what do I get? I get 4. If I take, for example, 11, and I subtract, 15, and I subtract 11 from 15, I get 4. If that is the case, actually, if I take 11 and subtract the previous term, 7 from 11, I do get 4 as well. And same is true with the other terms. If we get the same difference, if we take a term and subtract the previous term from that term, then we have a common difference, quote unquote common. It should be common to all pairs of terms. So if you take a term, subtract the previous term to that term, you get a difference. And if that is the same difference, if you repeat the process, taking into consideration other terms, then you have a common difference. Let's now go to the formula for arithmetic sequences. So this is the formula for finding the nth term of an arithmetic sequence. A sub n is equal to a sub 1 plus the quantity of n minus 1 times d, where a sub n is the nth term. A sub 1 is the first term. N is the number of terms. And d is the common difference. So these are the four inclusions in our formula. The nth term, the first term, the number of terms, and the common difference. Let us go to our first example. So we have to determine the 10th term of the sequence, 4, 6, 8, 10. So let us take our formula. The formula a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. And we are going to identify each term in the formula from the given problem. So we have to determine the 10th term. So if we are determining the 10th term, then a sub n is equal to a sub 10 because we are looking for the 10th term. A sub 1, which is the first term from our problem, is 4. N is obviously 10. Why is it 10? Because the subscript n here is 10, so therefore n is 10. And besides, we are looking for the 10th term, so we assume that we have 10 terms all in all. And then the common difference, sorry, let's have the red pen color. So the common difference is the difference between any two consecutive terms. So you just take any term and then subtract the previous term, and that is the common difference. Most of the time, normally, we just take a sub 2 and subtract a sub 1 from that. So that is going to be 6 minus 4, which is 2. Therefore, our common difference is 2. After listing down everything from the problem, then we can now just plug these in our formula. So we have a sub n, which is a sub 10, that's equal to a sub 1, 4, plus the quantity of n, that is 10 minus 1 times d, which is 2. From here on, we just simplify for the final answer. So we have 4 plus 10 minus 1, that is 9, times 2, that is 18. And then just add for our final answer, a sub 10 is 22. But this problem is very simple because the terms in our arithmetic sequence are all whole numbers. But what if the terms are fractional? Let us go to example number 2. So we have to determine the ninth term of the sequence: 2 over 5, 11 over 15, 16 over 15, and 7 over 5. So let us write our formula first. A sub n equal to a sub 1 plus the quantity of n minus 1 times d, and identify the terms in our formula from the problem. So we have a sub n, which is a sub 9, because we are looking for the ninth term this time around. We have a sub 1, the first term, which is 2 over 5, n, which is 9, why 9? Again, because we have our subscript that is 9, so n is equal to 9. And also because we are looking for the ninth term. But what about d? D now is equal to, we are going to solve now for d, because we cannot readily identify what d is. Unlike in our first example, where we can just mentally compute for d. That's just a sub 2 minus a sub 1, 6 minus 4, that's already 2. But this time around, we are given fractional terms, so we can't do that. Customarily, to solve for d, we use a sub 2 minus a sub 1. Customarily, but you can use other terms, and we are going to do that actually later. But let us just try this customarily thing. So we have 11 over 15 minus 2 over 5. To subtract 2 over 5 from 11 over 15, maybe we can get the LCD. What is the LCD of 15 and 5? So that is 15. Then 15 divided by 15, that's 1, times 11, that's 11, minus 15 divided by 5, that is 3. 3 times 2, that is 6. So 11 minus 6, that is 5 over 15, which if we reduce to its simplest form is 1 over 3. So this is our common difference, 1/3. But we solved 1/3 using the customarily thing a sub 2 minus a sub 1. But we can actually just take into consideration other terms, and we can still come up with 1 over 3. How do we do that? So let's take this 16 over 15 and this 11 over 15. Instead of taking a sub 2 minus a sub 1, we take a sub 3 minus a sub 2. I'll write it here. So d is equal to a sub 3 minus a sub 2. Can that be? Yes, because according to our definition, we are going back there, it is the constant derived by subtracting any two consecutive terms. So for as long as the terms are consecutive, we can take them, the difference of those terms, and still get the same common difference. Because if we do this, this is going to be 16 over 15 minus 11 over 15, which are similar fractions. So we have to just copy the denominator and then operate on the numerator, that is 16 minus 11 is 5 over 15, or 1 over 3, or 1/3 if we reduce it to simplest form, which is just the same, 1/3. Okay, so you can use that easier method, or you can just use the customary method. That's also fine with us, for as long as you get 1/3 as your common difference. After identifying all these, just plug in our formula. So we will have a sub 9 is equal to 2 over 5 plus the quantity of 9 minus 1 times 1/3. Simplifying further, we will have 2 over 5 plus 9 minus 1 is 8 times 1/3. So that's 8 over 3. For those who did not get that, let me use another pen color and write it here. So 9 minus 1 is going to be 8 times 1/3. So this is a whole number multiplied by a fraction, and the whole number has a denominator of 1. So you just multiply the numerator by the numerator and the denominator by the denominator, giving us 8 over 3. Going back to our solution, we have 2/5 plus 8/3, so we can add this by getting the LCD, which is 15. So 15 divided by 5, that's 3, times 2, that is 6, plus 15 divided by 3, that's 5, times 8, that is 40. Or you can just simply do multiplications. So multiply 5 and 3, you get 15 here. You multiply 2 and 3, you get 6 here. And then you multiply 8 and 5, you get 40 here. You can also do that. Now, going back to our solution. So 6 plus 40, that is 46 over 15. If you can simplify this or reduce it to its simplest form, you can do that. But I think this is our final answer already. So let us have our third example. Find two arithmetic means between 2 and 8. So to find two arithmetic means between 2 and 8, we can diagram first the whole sequence. So we have 2, and then we can insert the two arithmetic means between 2 and 8. So this is our first arithmetic mean, this is our second arithmetic mean, and this is 8. Because according to our problem, we have to find those two arithmetic means between 2 and 8. So we inserted them in between 2 and 8, thus giving us how many terms? So we have 1, 2, 3, 4. So we have 4 terms. What we want to do first is to solve for D. Solve for D using our formula. What is our formula? a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. What is a sub n? A sub n, as what we have mentioned, is the nth term. We assume that that is the last term. For example, ninth term. So we assume that we have 9 terms all in all. So a sub 9 is the last term. That's what we are going to do here as well. So we take 8 as our assumed last term. So we have 8 is equal to a sub 1, that is 2, plus the quantity of n. How many terms do we have? 4 minus 1 times d. We are solving for d. So let us simplify further. 8 is equal to 2 plus 4 minus 1, 3 times d, 3d. Since we are solving for d, we should isolate this on one side of the equation. So we should transpose 2 to the other side, which will give us 8 minus 2 is equal to 3d. But 8 minus 2 is 6, which is equal to 3d. To solve for d, divide both sides by 3. So we can cancel, and we are left with d, which is 6 over 3, or 2. If we have our common difference and the sequence is arithmetic, so what we just do now is to simply add the common difference from the first term. So 2, the common difference is also 2. So just 2 plus 2, 4. And then add 2 again, 6. To check if our answer is correct, if we add the common difference to this 6, we should get 8. And we got 8. So these are the two arithmetic means between 2 and 8.